Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to today's webinar, Beyond 1% Industrial AI for a Better Future. My name is Amanda from Engineers Australia. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them and their cultures and to elders past and present. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Siemens. Siemens is a global technology powerhouse that started its Australian operations in 1872, celebrating more than 150 years of operations in Australia and more than 175 years of operations globally. Today, Siemens brings together the digital and physical worlds to benefit customers and society. Active around the world, the company focuses on industry, infrastructure, mobility, and healthcare. This includes intelligent infrastructure for buildings, distributed energy systems, and automation and digitalization in the process and manufacturing industries. Creating technologies for more resource-efficient factories and resilient supply chains, smarter building and grids, cleaner, comfortable transportation, and advanced healthcare. The company empowers customers to modernize the industries that form the backbone of economies, transforming the everyday for billions of people around the world. Today, we will hear from our expert speakers in an insightful panel discussion. And I'd now like to welcome our moderator for today's session, Keith Ritchie, Head of Communications and Government Affairs, Siemens. Keith is a thought leader, futurist, and storyteller. He has been instrumental in driving topics around the energy transition, green hydrogen, smart infrastructure, digitalisation and Industry 4.0, including his role in establishing the Prime Minister's Industry 4.0 task force. He believes that accelerating digitalisation and technology is critically linked to achieving positive outcomes for business, the economy, society and climate change. Keith is behind the visionary concept of Beyond 1%, which explores how Australia could decarbonise the world well beyond our emissions. Please welcome Keith Ritchie.
Thanks to Engineers Australia for that great introduction. It's a pleasure to be here today on a topic which I think is, it's very sexy at the moment, this topic in fact. There's a saying in showbiz that sometimes a great artist gets a #1 hit and says it took me 20 years, to become famous sort of thing overnight, an overnight success. So Siemens has been involved in artificial intelligence for about 50 years now. And the topic of AI seems to have really taken off, but for good reason. And today we've got experts with us from different industries and different backgrounds, representing different opinions. So we're going to have a pretty free-flowing conversation, and hopefully some engineers out there listening will get a lot out of this. I'll start with Rick. Rick Irons-McLean is the Chief Technology Officer of Microsoft. I'll come back to each of you for a bit of an explanation, understanding of what you actually do. Alex Hill is a founder of Sensei, which is an AI tool which Siemens has acquired. And Hanno Blankenstein is also the founder and owner of Unleash Live, which is visual AI. But maybe let you guys describe what you actually do. Start with Rick.
It's a really interesting thing. I don't quite know what I do half the time, to be honest, Keith. But and also, whenever you introduce people as experts, there's always setting a big expectation.
Start sweating.
You start sweating, yeah. So I'm the Chief Technology Officer for Microsoft's enterprise commercial business across Australia, New Zealand. I'm an external-facing Chief Technology Officer, so I spend all of my time working with customers and industry groups to really look at how technology like AI can be leveraged to deliver outcomes. Because at the end of the day, AI is a tool, like other things like IoT and cloud, it's a tool. So for me, it's how we actually get value out of that, and that's what I spend most of my time doing.
Okay, Alex?
So we started 10 years ago to develop AI to help monitor machines at industrial enterprise scale. So yeah, we can cover the 50 machines, the 100 machines, but that's traditional condition monitoring. In our frame of mind, when we talk about enterprise predictive maintenance, it's the whole enterprise, tens of thousands of machines, everything from lighting systems to a transformer to a conveyor to whatever there is. And AI is core to that because humans are not very good at monitoring tens of thousands of machines just by themselves.
Okay. Hanno.
Thanks, Keith. At Unleash, we believe vision is actually your most powerful sense. So we are specialized to extract data from computer vision or through computer vision, which is one area of AI. And we are connected into your traditional CCTV cameras, it can be drone cameras, robotics cameras, and we then use computer vision to really help monitoring of critical infrastructure, but also large-scale infrastructure such as roads, power lines, wind farms, and in effect, we supercharge your camera network to extract data for your maintenance and operational efficiency.
Okay. Rick, I attended last year in December, I attended the Microsoft AI Summit in Sydney.
Yep.
And there's a couple of things that really stuck in my mind. And I guess it brought a light bulb moment on the sheer pace of change with AI. One of them was, I seem to recall your COO, global COO, saying that in 18 months, Microsoft has built a $10 billion AI business, basically. Is that correct, something like that?
I'm not going to go into the specifics of the numbers,
Yeah.
but it's that level of pace and it's that level of output and revenue that we are seeing. So, and I think that's something that's going to continue to grow exponentially, particularly if you think early on. We're still at the nascent stages of generative AI development, which is really what's accelerating the AI transformation. And we haven't yet seen this scaled out across the world, across multiple organizations yet. So I think we're going to continue to see that as AI itself, particularly Gen AI, becomes more and more capable and it delivers more and more value and outcomes. So I think it's definitely a trajectory that's going up like that, Keith.
Yeah. Yeah. So in the context of what we're here for today, this series that we've been running with Engineers Australia is around the topic of beyond 1%. And the 1% represents the greenhouse gas emissions that the nation is responsible for. Everything that we do, every commitment we've made, the net zero 2050 commitment, the energy transition, the greenhouse gas targets, all of that is to address the 1% of emissions that we're responsible for globally. And we believe actually if you accelerate technology and digitalisation, including AI, Australia could contribute to decarbonising the world by a lot more than 1%. So that's what we're really wanting to explore today. And sometimes we have to unpack that to see and put a different lens over what these outcomes are, where our emissions sit. What sort of things, you talked about predictive maintenance, Alex. How does predictive maintenance have any impact on sustainability?
That's a great question. And usually in the market, when people talk about predictive maintenance, they're talking about fundamentals of avoiding unplanned downtime. And sure, that's important. When you want to use your machines, you want them working. And it's a basic principle of if I can't produce my product, then I can't sell it and I can't make money. But we find that a reasonably unsophisticated argument. Unplanned downtime is cost avoidance. You never plan to spend it. But as you get more and more into understanding and doing this at scale, and when you start to look at an entire enterprise and all of the machines, the level of data and the things that you can explore there, you start to be able to say, well, actually, I don't need to perform these inspections as often. I don't need to go to the site as often. I can actually now turn my capital acquisition of this machine into a longer term payback, because maybe I only expected this machine to last 7 years. But actually, with the information that I'm looking at through predictive maintenance, I have the confidence now to say, well, I can extend the lifetime to 10 years.
Okay.
And so you're turning the conversation of sustainability and predictive maintenance from a cost center into a real cost saving. That's money that you can put in your pocket. It's money that you had budgeted for that you don't need to spend. And then you have all of the knock-on effects of, well, if your machines are behaving better, they're likely to use less energy, they're likely to break down less, and spill something or cause some form of environmental damage. And all of these things knock up. But you need a very sophisticated system to be able to capture that information, process it, and work with it. And humans aren't very good at that when it's at scale. So we started developing Senseye 10 years ago to really codify that and make it simple for humans. We talk about machines all the time. It's ultimately about humans. How can we make their jobs easier?
Yep.
How can we make this story better?
Okay. Hanno, give us an example of where you talked about this vision being at the core, and how does that work with AI? Give me an example so I understand what you're actually talking about.
Sure, and being partners of Senseye, we see that it all starts with actually capturing really accurate and good data in the field at scale. And you can do that manually. So at the moment, there are many, many engineers and humans just collecting all sorts of data.
Yep.
Infrequently, often on paper, or sometimes they have an Excel sheet. It's siloed, so it sits on their laptop. So that is a problem, because if you have 300 wind turbines or 750,000 power poles or large machinery spread across the world in iron ore mines, you struggle with actually understanding the performance, the lifetime of your assets, when maintenance is required, etc. So now, clearly, in the last years, there was a trend towards IoT.
Mm-hmm.
So you put sensors onto machines, or you extract digital data from your machinery, which is fine, but comes with a lot of challenges. You need to deploy hardware, you need to connect the hardware, you need to maintain the hardware, so you have another asset in the field. And so with computer vision, what we believe is a very complementary data set to IoT and the manual-based inspections is just putting data into cameras. You see that, for example, all of the conveyor belts in the Pilbara are actually connected with more than 80,000 cameras. They are often used for security. And now we inject more insights into those camera systems. So now suddenly you can analyze things as depth, speed, heat, vibration. All of those things exist through computer vision. And it's fascinating that our eyes actually sense the same things that I just talked about.
Yep.
Your eyes can sense depth. Your eyes can sense vibration. And it is extremely powerful. So suddenly you don't have a single IoT sensor anymore to put a vibration sensor somewhere. You can just have a multi-sensor environment with existing camera systems. Now you can take that into further automation and say, why don't you just deploy it on moving cameras such as drones or robots moving through a factory or flying across transmission lines? And it becomes a sensor that is not fixed to a machinery in one place, but you actually can almost collect. It's like a scout that collects the data. And so if you have that paradigm of scale, automation, and low-cost data capture, then you can really power up tools like Azure Cloud or Excel or Senseye, which suddenly then produces much more insightful data. And it's not siloed anymore, and it's not static anymore.
I love the multiple use cases there. Of people understand vision, they understand putting cameras places. There's a use for that already. You can make use of existing investments and take it to this much more interesting use case where you're talking about efficiency, sustainability, and all these other things with a technology that's really well established.
It's already there.
Yeah.
And when you look at I think the trend really accelerated with the iPhone, right? You can think of the iPhone as a consumer device, but what it did was the camera in phones suddenly made it accessible for anyone, not only engineers, but everyone understood the power of photography, first of all, for the consumer market, but then suddenly Apple added LiDAR as a complementary sensor. It added depth into the sensoring. So it's amazing how when you couple software with the camera sensor, what is possible.
Yeah.
And previously with your traditional CCTV or your SLRs, you never had that power. So it's amazing how you can back-end all of this with strong compute power in the cloud or on-prem, and you get this rich multi-sensor environment.
And it's in your pocket.
Yeah, before we kind of go off this, I'd like to probably address the elephant in the room first of all, because we're already jumping into how do we solution using AI and so on to solve sustainability. I think we have to look at this in two ways. We know that there's going to be an impact on sustainability, particularly environmental or climate, through the use of AI. And we can't get away from that. We don't know what that's going to look like yet because we're not yet running multiple scaled AI workloads all around the world. So there will be an impact. There'll be more energy consumption. There'll be potentially more water consumption and so on, and then more materials as we build data centers. So we actually have to think, first of all, how do we mitigate against the impact of AI on sustainability, particularly the environment? So like at Microsoft, when we build our data centers, they all run now 100% on low carbon energy sources. Any of our new data centers, the AI ones that come online, they don't use water for the cooling process. It's alternative liquid cooling, cooling plates and so on. In the materials that we actually use to build it, we're actually using low carbon steel, low carbon cement. We're even building our first data center in the US, which is made of wood. So there's a whole load of things we can do.
So cool.
We also know that the components, server components and so on, are getting more efficient over time, so they draw less energy. But there is going to be an impact. So we have to be responsible as organizations, particularly large organizations, to make sure we mitigate against that impact. However, we also know if you flip that around, that the only way we're going to solve some of the big sustainability challenges is through the use of AI. And we can't get around that. So if you think about, large complex modeling for the next generation power utility grid, how do you model what renewable energy looks like when it integrates? How do you actually operate that dynamically when you've got multiple different sources that may be going up and down at the same time? How do you predict climate change modeling, risk modeling? It has to be done via AI. To your point earlier, Alex, there's no human that can do this.
No.
So we have to think about leveraging AI for these types of capabilities, and across use cases, AI can do this. So in the Climate Leaders Coalition of Australia at the moment, Microsoft are leading up a group on AI, and we'll have 2 publications coming out in March and April. The first one will be how any organization can think about mitigating that impact. The second one is really looking at how we take AI, which is, as I said, a tool, and we start to map that to different industry use cases to say this is how we can solve some of those sticky problems in each industry, which may be slightly different. So I think it's really important we take that responsibility, first of all, to say there could be an impact, we must mitigate, but then really flip this around and say, to your point, how do we not only solve Australia's problems, how do we go beyond that and look at how we have a better economy, how we can compete on a global scale beyond 1%?
In some ways, what you've described is the philosophy of net zero itself. So philosophically, to achieve net zero, you are meant to make your operations as efficient as they possibly can before you rely on offsetting. And that's exactly what you've described. But I think that flip side is really important. Data centers is one thing. Of course, you need more and more data centers to handle that huge amount of data, but we know that there might be developments there on the way the chips are designed, and quantum computing and other things, which will reduce the size required, the heat generated, and so on.
And the software engineering and the improvement in the models, which we're already seeing. So you're absolutely spot on.
So this is an improvement that will definitely take place.
It's an exponential improvement, because now you can use AI to improve the operations of your AI data center and achieve a level of granularity in that control and sophistication and efficiency that would drive a human team wild.
And I think this is a really important point about how there are 2 elements here, right? And I might just be summarizing it in a different way, but there's AI and the capability of AI. We produce more energy, we consume more energy through the use of AI, which is a concern. But then you have the energy production and the energy transmission and distribution. So it's almost like we can put lots of Teslas and e-mobility into our transport system, but unless we have the energy generation not coal-fired anymore, there's no effect, right? So to your point, net zero really has to address the entire value chain, of scope 1, scope 2, and scope 3.
Yeah.
And one anecdote or example, I recently had a conversation with the CEO of one of our clients, the transmission and distribution company. And through our drone flights, where we completely automate the inspections, we save about 70,000 engineering callouts, and they actually analyze the data in the office instead of going out into the field. Number one. So that's just cost avoidance, but also carbon avoidance. Mm-hmm. The second big point is, to your point, we actually, with the drone analysis of computer vision, we can look at the thickness of the conductor cables. A human is unable to actually see how thick the conductor cable is, and it's extremely complex to analyze. With the drones and the sensoring, we can do that in real time. And so he said there's probably 1 gigawatt just tied up in the cables itself. That's like almost a nuclear power plant. Mm. And so just optimizing and modeling how you unlock that value and how you replace the cables to provide more data, more energy for data centers, unlocks a tremendous carbon avoidance.
So the UN have said that 79% of the sustainable development goals of the UN can be positively impacted by AI. So we know this is going to be a game changer, and is already. And I must share an example as well. One of our customers that we've done some work with, we jointly developed some algorithms, AI, that supported them. They came up with a way to clean the molds that make glass bottles using lasers instead of traditional methods, which is chemicals or ceramic bead blasting. So straight away you have a supply chain issue. You have to make chemicals somewhere, ship them somewhere, use them somewhere, dispose of them. That's one thing that's eliminated by using laser on the site. The challenge was mapping the path for the laser to follow to clean the molds without damaging the molds, because the other methods also damage the molds, to the point where every glass bottle mold requires an extra 1 gram of silica on average per year. Doesn't sound like much, but when you times it by 700 billion bottles a year, it's actually about 830 billion this year. But the calculations I did said that you can avoid the waste of silica, 700,000 tons of silica, in fact, which means that you avoid the energy used to convert the silica to molten glass, which means you avoid 1 billion kilos of CO2 a year in one industry through one innovation. And AI allows the path to be mapped in 2 seconds. So it's using algorithms to map that path so the laser can follow, and it eviscerates the material built up without damaging the mold. So it also extends the life of the mold. So you can see this is the sort of stuff that can happen. That innovation from Australia using tools and technologies is open and available to anyone. This is an SME. This is not a big company, this is an SME. That system is now being used in the US by the largest glass bottling company in the world. So you can see this is real, and that beyond 1% is very real when you start to apply things like AI. Rick,
I was just going to say, just picking up on something you said, which I think is probably really important to this conversation. We've mentioned the word or term sustainability quite a few times, but it's such a broad and nebulous term. And I think what we've done is typically do what most people out there do, is focus in on climate and the environment. And when we really think about sustainability, it's much broader than that. You mentioned the UN SDGs. We actually have the ability to use AI for multiple things outside of the climate and the environment piece. So if you look at health, using things like generative AI models to discover new drugs much quicker. We've just released a research paper, a peer-reviewed research paper at Microsoft on how we can actually accelerate that multiple times using generative AI models. But we can also look at this through education, through agriculture and improving crops, and even through things like skilling and human capital. AI has the ability to influence all of these areas. So it's a much broader topic than just climate and environment. But obviously climate and environment we need to get right, because you can't do those other things without having the right environment to operate.
It's really funny. I mean, we see when you take a very holistic view of especially net zero with scope 3 emissions, you have to take into account all of the things, the embedded carbon in the processes that you've described.
Absolutely.
If you can speed those processes up, you reduce a lot of embedded carbon. If you remove the factor of people having to send people out for days and transport them, and you can use drones instead, you're removing embedded carbon in the supply chain. So I think it's all very much interconnected, and the world's only really starting to understand that interconnected nature. We're moving away from just saying rapid transformation of renewables from fossils to a holistic decarbonisation approach.
Yeah. So on that point, there's probably, I think there's a big debate, and I'm sitting clearly on one side, and that's about, do you replace one way of producing energy with another one versus avoiding energy production in the first place?
Yeah.
And so clearly what you see today in politics and many papers is there's this notion that we'll produce as a planet, we'll produce, what is it? 3 times as much energy in the next 50 years versus today.
In Australia, actually, to meet the net zero 2050 target, we have to triple the energy capacity of Australia by 2030.
Right.
Triple it.
So there's this notion that we just produce more energy and then we'll solve the carbon challenges. I do believe we invest and think way too little about energy avoidance. How can you actually reduce what you do? And your point about, if we are using AI more, then we can actually use that to the benefit of actually not powering the data center with so much energy in the first place. And so the notion of having less call outs is a great one, because you just don't need to take that trip anymore. And the same is true if we look at core processes across key industries. There's just a negative way you can say there's just so much waste.
Yeah.
So much waste. And we as a First Nation, as a kind of developed nation, we just produce so much waste in the way we behave, the way we use digital technology, etc. So let's go back to first principles and say, where can we take our waste out of the processes, and then rebuild those processes digitally and with the power of AI.
With sustainability and the energy usage of particularly generative AI is tremendously energy inefficient right now. But it's important that we remind ourselves that today is the worst day that will ever be. It's getting more and more efficient all the time, and now we've entered this exponential curve where we can use generative AI and all these technologies to improve our energy consumption and energy use, and interesting things are going to happen where we're now using generative AI, like you said, to perform research and accelerate that curve of new energy technologies and fusion energy, those kinds of things.
Rick, I seem to recall that Microsoft saying one of the things that they did with AI in particular is improve their own business and their own operations.
Yep.
What sort of improvements have you seen with AI for Microsoft before you even take this to customers?
Yeah, so I'd say that although we talk about this as being the era of AI because of generative AI over the last couple of years, AI is not new. It's been around since the 50s, machine learning since the 90s, deep learning since the 2010s, and then Gen AI is the 2020s. So it's been around for some time. We've been infusing AI, traditional AI, across our business since probably 2015, 2016. I mean, at large scale. We've been obviously using it before. So we've already seen a number of improvements from that perspective. But I think what we've really seen over the last couple of years with generative AI, because it can now do things like create net new content, we can now use full agents or agentic AI to fully automate processes. We can interact with AI in a completely different way, as in we can talk to it. And we can actually start to build things like agentic AI models using human language. So build me this. I'd like you as an agent to be chirpy today, to be happy today, to solve things or to respond in a certain way. So we're now really able to interact and understand what AI can do in a much more human-like fashion. And therefore, I'm seeing a lot more adoption inside of our business. So we use it across all of our business, infused into everything, a combination of AI and Gen AI. We released a paper called our Work Trends Index. We did one in 2023, one in 2024. And that will give you an insight in terms of how we're using it across all of our business for operation efficiencies, improvement in terms of personal productivity, and those sorts of things.
So you've taken your own medicine.
You have to. It's the only way to really learn it. The only way you'll understand AI is to put it in the hands of the people that are going to be using it, to really understand how does it work. It's a tool. It is a tool. So how's it going to be
Democratizing it now in a way.
used? Democratizing that.
Now AI is no longer about these super sophisticated engineers and scientists.
It's not.
Anyone can now use AI,
Yep.
and that's the potential for the human spirit of creativity to work with this machine that knows everything effectively.
Absolutely.
And we're going to see some really wild things coming out of that, I think.
We will. But to go back to those kind of core processes that you asked about, so we've got a lot of statistics we've kind of put out there in terms of across the business, what does that look like? But if you take one of those areas like our customer service, so as you expect with Microsoft, you've got a lot of digital tooling, people raise support cases, both businesses and also for humans like us who may be at home playing on an Xbox. So we've actually really started to put agentic AI or agent AI into our contact centers, our service centers. And we actually now have 30% of all queries from businesses that come in are handled fully autonomously, no human in the loop. And 75% of all commercial inquiries that come in, like from us at home, are dealt with by agents, so no human in the loop. Charles Lamana, who's one of our corporate vice presidents looking to the future, thinks that in 3 years' time we'll start to see our fully autonomous contact or service centers, so no humans in there at all. Because the whole point here is most of the processes in there are boring, can be automated, can be streamlined. Mm-hmm. And what you really get with this agentic approach is to be able to automate those, free the humans up to actually do more meaningful tasks. Yeah. But also with agents now, they can respond to people in real time. They can actually give you a much more personalized experience and do it a lot quicker. So we're really starting to put that across our business, but we put it across our business where it makes sense to do it. We don't just throw Gen A out and use it as a hammer to try and solve everything. Yeah.
One of the things, each of you were hand selected to be on this panel for a reason. Siemens is the largest industrial software company in the world, the largest automation company in the world, and the largest electrification technology company in the world. We want to accelerate digitalization because we believe that it will have all of these sustainability benefits and that Australia in particular could do a lot more for the world. But one thing we do know is that we can't do it alone. Even though we have all of that, we can't do it alone. So the point of collaboration, we are collaborating with each of you in different ways. Sensei, of course, we liked it so much, we acquired it, right?
It's an old story, isn't it? Like so much we bought the product.
Yeah, great to have a founder here. With Microsoft, we have the Microsoft we have the industrial co-pilot. And with Unleash Live, you're also an accredited ecosystem partner on the Siemens Accelerator Digital Business Platform. And all of you are actually accredited ecosystem partners. How important is it? What happens when you collaborate and combine this stuff? I mean, Microsoft is huge, right? Surely you could solve the problems of the world without anyone else.
So I really wish we could say yes, and I'm sure our shareholders will be very happy with that answer, but it's just not a reality. We are specialists in digital and technology and really innovating around that. But all of the stuff we're talking about are tools to be able to help solve other outcomes. We're never going to be experts in things like process automation, industrial automation, and so on. We have pockets of expertise to really understand how the tools work. So when we put those skill sets together, this is where we start to solve problems. And we're starting to work with Siemens, as an example, looking at some of the energy precincts in Australia. Because if you actually think about that, you've got multiple different industries coming together to try and solve a regional problem. And in that, you might have businesses who are looking at fossil fuels, you might have businesses looking at renewable energy, you might have businesses looking after community engagement, we've got jobs, we've got housing services, infrastructure. One company can't solve all of that. Yes, we can put infrastructure and tools in place that might bring that together. We might be able to use AI to accelerate some of those processes, but we're not going to be experts in all those different domains. So the only way we're going to improve this is by leveraging tools like this, but with the expertise of those domains to actually drive things forward. So collaboration is essential for me, Keith.
Okay.
It's an ecosystem, isn't it? Like we see that predictive maintenance, that's a very narrow topic, and it has certain areas that we can affect, like efficiency and sustainability, but we're aware that this is part of a wider picture. We're focusing on the puzzle piece, and we want to build the best puzzle piece that understands how to best behave with these machines and help humans do that. But we're not doing that in isolation. It's connected to your maintenance management system. It's connected to your ERP system. It's connected to everything so that you have this holistic picture of how you can improve overall efficiency and sustainability. And we're working on this puzzle piece that is designed from the ground up to connect with all these other puzzle pieces.
I would totally agree. I think the ecosystem that Siemens is building is so essential to actually avoid the disappointments of the first digitization era, which is kind of like in the 2000s, where again you had siloed elements, and it was really, really difficult for developers or engineers or the business user to put it all together. So I think now we have the opportunity to really, and today is a great example. We every day when we work with our clients who are part of this ecosystem, they look at which cloud services do I need, how much compute and how good is the compute to actually give me real-time results on data. How do I present the data back to my business stakeholders, to my CEO, to my investors? And that's Sensei with a great visualization platform. How do I connect it all up into a workflow? So how do I modularize it with hardware that sits at the machinery or sits in the warehouse? And that's where Siemens comes in with the really strong automation tooling that you have. And so you need to, if you want a business outcome, you can only work in an ecosystem where you connect those puzzle pieces and you actually stick to your swim lane and then work with partners instead of trying to solve everything.
So combining your visual AI, say with automation technology, would create some other form of magic that otherwise doesn't exist. Yeah,
absolutely essential. We could not even physically deploy our technology unless we would have partners like Siemens and others that are really strong in the industrial automation space.
It's not one size fits all either. It's and we saw the one size fits all approach, and Siemens even tried it 10 years ago, and customers don't want a monolith. They want best of breed in these sections. They want sometimes a company to solve that for them and put that package together for them. And so like the Siemens Accelerator is a really good way to do that. But ultimately they want choice because these businesses are unique. Mm-hmm. We can't treat them as the same business and you get the same monolithic solution no matter what. You need something that's actually going to be interoperable and allow people to still exercise some choice and flexibility.
Another trend, or I think finally a good trend, is that we, like as businesses, there's not even an intention to lock the user or the customer into a certain technology or system, because you actually have modules and the world is moving so fast in digital.
So interoperable, open.
You need to accept
software
that.
as a service.
And that's actually your differentiation. If there's a new LLM coming around next week called DeepSeek 25, we can integrate it, and we shouldn't.
Anything with DeepSeek, I'm not sure. We might have to assess
Copilot.
Copilot 28.
Copilot everything, okay.
Does it get bleeped out?
And there will be definitely some other great fancy name to be another great module to plug in. So that awareness and that architecture, I think customers demand from modern businesses like us.
Siemens recently released a report called A New Pace of Change, which is about the connection between AI and sustainability. It's a really interesting report, interviewing over 200 global leaders and a number of organizations behind this. And 91% of those interviewed said that AI will help them achieve their sustainability goals over the next few years. We'll put the link into the webinar so people can have a look at that. But it brings me to the final point I want to discuss, which is really for the engineers in the room, because engineers play a critical role in the world achieving the transformation and transformations that we need to achieve to sustain the future. Engineers are at the heart of this. But in Australia, we have something like a shortage predicted of 50,000 engineers short. The majority of engineers in the country are actually imported into the country. So we have a real skill shortage. Industrial Copilot is designed to address that skill shortage. How does it address the skill shortage? And I want to ask this question, the old question, will a robot take my job? Will AI take the job of an engineer, or will it help the job of an engineer? Like I really want to unpack that a little bit as a final point. And then, I guess from each of you, what would your one piece of advice be to engineers who are listening in? What should they be doing in regards to AI? So that's how we're going to close. So let's go to Rick first.
I knew it would be me first. Thanks, Keith. I'm going to start with the last bit, which is I don't think in the short term, particularly from an engineering perspective, where you need a lot of different types of expertise, that AI will be replacing jobs. I think it will really be designed to augment and enhance jobs, and also help with transitions into other careers that we might need for sustainability. So from an engineering perspective, I would actually say, don't be so scared about AI taking your job. Be scared about other engineers who are really using AI to accelerate their business, because they'll be the people that actually replace you. I think it will replace a lot of automation and business function process. That's the sort of things that I think it will start to get rid of. We've got a report that we did with Boston Consultancy Group looking at the sustainability skills gap in Australia. This is a couple of years old, but it's very true to today, and we can paste that link in as well.
Yep.
But there's a known gap, both in terms of sustainability skills, but also in terms of technology skills, which we'll need to take advantage as we go through this transition. The thing I'd always think about, though, is what is it we're trying to do with solving this skill problem? Because I think quite often we say, well, we've got someone who might be, working in the fossil fuel industry. How do we start to transition them to solve a problem? Personally, I think it's going to take a little bit of time for our energy transition to happen. So I'd be using things like AI to predict what will the jobs be looking like in 5 years' time, 10 years' time, and then start to build the right pathways for skilling to be able to see people transition. And that'll be people in existing jobs who need to transition. It'll be people who need to have additional skill sets as part of that transition, and really look at our upcoming next wave of people who are younger than us, because they'll be the ones actually doing and running these jobs in an AI-centric world. So yeah, don't be scared about AI taking your job in the next couple of years, but really look out for people who are leveraging it, because people are doing this today.
Alex?
Yeah, it's not the next couple of years going to take my job thing. And part of our argument is, look, do you actually really want to be doing this job as well? And it can help you make this job less painful. One of the case studies I really like to talk about, and we've got a podcast about this called Trend Detection. It's an interview with
Trend Detection.
And it's published on the Siemens official channels. And part of it is a 3 or 4 part series with a gentleman with the fantastic name of James Bond. And he's this old school condition monitoring guy. He's the kind of guy that would go out with his box and stick it on a machine, and he understands that intimately. And on a good day, he would have been able to go into maybe 50 machines and analyze that. And then he's got to spend time looking at squiggly lines and understand what I need to do about this. And Sensei now helps him to monitor, just in one area of a plant, over 2,500 machines, just by himself. And it helps him to do that completely, 20 minutes in the morning. That's his process. And then he can go and do something else that is much more, I don't want to say meaningful, but has more impact than just looking at some data and trying to figure out what he needs to do about it. Because we can help him do that. Then he can use his expertise to actually say, well, okay, this is what we actually need to do about it. This is the team that I need to bring in to fix something. And so it's about acceleration of capability. And yeah, the number one piece of advice I have to engineers is start to embrace this technology, start to learn it, start to see how you can come up with new things and accelerate the stuff that you don't really enjoy doing, because you can really now focus your creativity. And at its core, I fundamentally believe engineering should be a creative subject. So let's get rid of the mundanity in some of these things and focus on actually the qualities of humanity that make us creative and spontaneous and curious, and we can combine the best of both.
And sorry to jump in, there's no shortage of skills and training courses out there. So if you look across LinkedIn, there's free to use, full kind of end-to-end, whether it's business value or the technology itself, training courses that engineers can use. Microsoft have just launched another course with EY, where we're really focusing on the next generation, so universities and schools, for AI skills for the future, and also underserved communities, because we want to connect people who may not be in the workforce today and get them ready for the workforce of the future. And we also have, across Australia, we've committed with our enterprise skilling initiative to training the millions of people on AI skills for the future. So there's no shortage. I think the most important thing is for people to get out there and learn what it means, but learn what it means in the context of their job and where they want to go from a career perspective.
Okay, thank you. Hanno?
I think there's not much to add. This is exactly the thought process I think we all have at the moment, whether this is a dangerous and kind of daunting future, or whether it's something we should embrace. And I would say change is the only constant, right? So we see, like you, just the examples that you provided, we see that every day with our clients, just using the tools and suddenly being much more empowered. So it's the opposite of fear. It's actually when you use AI, you feel like your creativity and your human self comes to the fore. And I think we'll see much more of that. We also see it in our next generation. So, and I think it's always a good idea to look at the youth. They just embrace AI without even questioning it, because they don't have this legacy that we have. So I haven't used the typewriter, so I don't think we should go back to typewriting. And the same will happen with AI. Our youth will not send emails anymore and so forth.
On that
So
point, then, I question if we'll even call it AI in the future, much like the information superhighway, or I'd say even IoT now is a somewhat archaic term. Are we going to be talking about AI in the next few years, or is it just going to be, this is how this works?
yeah,
So-
there's a branding attempt with Copilot by
I'm not going to call it Copilot. It just works. I think my marketing team would not give me a job. So,
But I think one of the, you talked about creativity, and I think we need to, so if, one sense of reality here is, or a reality check is, in anything that we do with AI, we need to think about how to preserve the creativity and the ingenuity of humans. I do believe that AI at the moment poses the risk that we become very bland as a planet, and that cannot happen. So I think it's on to us to actually look at how can we keep being creative as humans, collaborating, communicating well, and actually, back to business, reducing waste, because we as humans are not necessarily known to be a species that is very protective of our planet. So therefore, if we use AI, back to this theme here, one of the themes that I would love to get through with AI is just to look at waste reduction, making sure that we deploy it into processes that support humans in their creativity, instead of just putting us into a bland brown soup.
So if I sum that up, I think AI combined, we can't ignore the human factor to really leverage the benefits of AI for the benefit of the world. And at Siemens, one of our strategic priorities we call growth mindset. And I think this comes back to your point, Rick, to keep a curious mind, lateral thinking, creative thinking, and continuous thirst for learning and knowledge. And that's probably what engineers could focus on here. There's no shortage of material available. Just be the curious mind, the creative mind, and you'll be part of a great future. Thank you very much to the panelists today. I think it's been a great conversation. We could probably go on for another hour or two, and we might have to do that at another time over a drink. But thanks very much, and thanks to all the engineers that joined us. Thank you.
Thank you, everyone.
thank you.